Hi everyone, this short video is going to be a demonstration of how to do vector dot products. Now I've got an example here of two vectors A and B in Cartesian form. If I want to do the dot product, so it's called the dot product because we use a dot for multiplication instead of a cross, then I write the two vectors, 3, 1, again the dot, not a cross, -1, 2. Now this is really very straightforward. We take the x component of the first one and multiply by the x component of the second one. Then we keep going. We do the y component times the y component. Now this is only a two-dimensional vector, so there's only two components to worry about. So I have -3 plus 2, and that comes to a dot product of -1. The dot product is also called the scalar product because we have a vector multiplied by a vector, but the result is a scalar, just a number. There's no direction, there's no brackets, it's just a single number for the answer. So that's that one. That's nice enough. Now, what if I had two vectors given in polar form? For instance, I might have the vector 5 at a heading of 40 degrees, and I might have the vector, a different vector B here. Actually, I probably should call these different names because I've used A and B above. So let's call this vector C and vector D. And let's say that vector D is 6 at a heading of 170 degrees. For this one, I'll do a small sketch. So 40 degrees is roughly off there somewhere. That angle there is 40 degrees, and that's a length of 5 for the vector. Then 170 degrees is way out there, and 170 measures all the way around like that, and that's a length of 6 for the vector. Now the rule for dot product when we're in polar form is we want the length of vector C multiplied by the length of vector D by the cosine of theta. Theta is the smaller of the angles between them. So if I just highlight here, the smaller of the two angles between the vectors is there. Now I already have the length of C, that's 5, and I have the length of D, that's 6. Now what's the angle between these vectors? Well, if we subtract 40 from 170, we have 130 degrees. And a quick turn on the calculator should give me the result that I'm looking for. I get the number -19.3. And it is just a number, and I've rounded it slightly. So this is how we do dot products. If we have vectors in Cartesian form, like this, we multiply the x components, we multiply the y components, and we add them together to get a single number as the answer, a scalar. If we have vectors in polar form, we draw a quick diagram, and the diagram is mainly to think about the angles so that I can find the smaller of the two angles between the vectors, the one with the little red arc there, and it's the difference, 170 take 40 in this case, but think about each one as you do it, and our rule is the length of C by the length of D by the cosine of the smaller angle between them. That's how we do dot products. Thanks for watching.